through incorporating digital technologies. So past 12 sessions are completed. This is the last session for us. Today we have the eminent speaker with us, Anita Rani Ramadas. She is going to give a insightful session, so make use of it. So thank you. I welcome Anita. You have to continue your session.
Okay, thank you, ma'am.
Today we have the introduction about you. Lizzie ma'am, you give the introduction about
Yes, ma'am. Yes, ma'am. Good evening, everyone. It is my great pleasure to introduce our esteemed resource person for today's session on enhanced threat detection through incorporating digital technologies. We are truly honored to have with us Ms. Anita Rani Ramdas, a highly accomplished IT professional with of quality assurance and engineering at Intel IAS Global, Pune, India. Ms. Anita Ramdas brings with her an impressive academic background. She holds a bachelor degree in engineering from Madurai Kamaraj University. She earned her master's degree in data science learning from IIT Bangalore. Her inspiring career journey reflects her dedication, resilience, and leadership. From starting as a programmer, she has risen through the ranks. Her accomplishments have been recognized with several prestigious awards, including Emerging Leader in 2018, Most Valued Delivery Leader in 2020, and People Leader in equally noteworthy. Beyond her professional achievement, she is deeply committed to mentoring and empowering the next generation of professionals. She actively contributes to preparing college students for careers in technology through initiatives such as Team Everest NGO and the Vidya Bharati program by celebrating life communities. Her contribution to the IT field have been widely acknowledged, including recognition as the budding CTO of the year in 2020 and strong commitment to community service, making her a true role model in the technology industry. It is an honor to have her with us today, and I am confident that her insights and experience enlightening and inspiring. Please join me in extending a warm welcome to Ms. Anita Rani Ramdas. Welcome you, ma'am. Now I kindly invite Ms. Anita Rani Ramdas to take over the session.
Excuse me. I'm sorry. Hey, thank you, Lizzie ma'am. Thank you, Amda ma'am. Okay, we will, again, my name is Anita. Like she said, I work for Intel IAS. I head a quality assurance team, which is a 320 member team spanning across Europe, India, and UK. I am sorry about the timing. Okay, I thought it is at 5:30. I am extremely sorry about the delay. Okay, we will go ahead and get started for the day. This is going to be yet another session for the cybersecurity for digital enhancement, and we are going to look at how and what ML looks like for us in terms of cybersecurity. Like the other day, I know most of the names right now, so I think uh, I want each one of you to be involved like we were involved in the previous session as well. Okay, so we will get started. We know what the topic for the day today is, isn't it? So we know that it is a case studies and the practical applications of machine learning. Okay, so I am catering this and driving this only relevant to cybersecurity. We're not talking about practical applications of ML everywhere. But before we get started, right, I want to get some feedback on how do we envision, each one of us in this group, what do we know about artificial intelligence? Broadly, it is categorized into three major categories, right? Because artificial intelligence is the bigger picture, or that is the broader category, and below which what we have machine learning. Okay, so some of you come forward, please give share your inputs on chat. Tell me what types of artificial intelligence that you're already aware of. Because if I directly talk about a case study of ML or AI, right, that might or might not be relevant. So let's get started with what types of AI that we are already aware of. I'll type in, okay? Strong AI, that is right, ma'am. Copilot, Gemini, that is right. That is generative AI. Weak AI, we have strong AI, weak AI. Yeah, generative AI. Gen AI. Yeah, that is right. The other day we had a lot of people responding. Okay, they're coming online again. Okay, nice. Okay. All right, OpenAI, that's right. Merlin. Okay. Okay, I'll go ahead and start sharing my screen while we see the inputs on the chat GPT. That's right, Usha ma'am. Okay. Let me know when you see my screen. Do you view my screen? Can everyone view my screen? Yes, okay, yes. All right, thank you. All right, okay, we will get started. See, this is going to be like a really lengthier session, but I try to minimize it and put it in a nicer way, which is easy for us to do within an hour and a half. Okay, so let's see what we'll take a look at this. Okay, artificial intelligence, it is basically categorized on three major categories, as you see on the screen. One is artificial narrow intelligence, general intelligence, and there is also super intelligence. So, well, and based on the functionality, they have internal functions. One is reactive machine AI, the other one is limited memory AI, and for AGI, it is theory of mind. For super intelligence, it is self-aware AI. Okay, we will not delve into each of these topics in detail because we have a lot more to look in correlation of AI with cybersecurity. Okay, that's the broader category. But when we delve into this and see what is each of this reactive machine, we say it is going to react to something. Okay, what happens is that what the capability is this response to immediate request based on the training that is provided to it. Okay, and then it lacks memory, lacks capability of learning from experience, works on limited input. Let me bring up an example. Okay, when something is reactive, what it means is you go to the classes. For the teachers, this is very, very common. Okay, you go to the classes, say network or say antennas, wave propagation, digital signal processing. You teach a Python topic, you teach a C++ or Java topic, you teach something about Spring Boot. And when you go to the classes, you teach the students, and at the end of the session, if you ask some questions, okay, hey, what do you think about this particular topic? What do you think about this? What is the answer for this particular question in digital signal processing? Probably they are immediately responding to it, okay, because the memory is fresh. They've been taught really well on that topic on that particular time, which is very confined. Okay, so that is how these reactive machines are as well. Spam emails, for example, you will see everybody knows about this. Is very common in email, Gmail, everywhere we go, we see spam. So what spam does is that they'll have a filtering technique which will say if you see this kind of words, example, say erroneous, money, okay, you have $100,000. You have been selected for say for a check is being provided to you. Sign in your details. When they see spam details like this in the filter, what happens is that spam emails will be pulled to the spam pool. Okay, and we will also see another thing, right? All in a sudden you will search something on Google, that populates on your Facebook, that populates on your YouTube, that advertisements are on your YouTube, everything happens there. So that's product recommendations. Okay, similarly we have Google Alpha, Deep Blue, IBM Deep Blue, kind of not a general one, but that is also a similar kind of reactive machine. Okay, like I said, it lacks memory, it doesn't learn anything from the past. Okay, and then we have AGI. AGI is theory of mind. What it does is it perceives and picks up emotions of others. It reads emotions, predicts future actions. We are already teaching it something, and what it does is based upon the teaching, based upon the interaction with the social humans, it uses the theory of mind. It is not fully realized. Right now, we're not using theory of mind in a lot of places, but Sophia, Sophia is trying to answer questions like, hey, Sophia, what's your name? What's your talent? You know the Sophia robot. Definitely you do know. Okay, so that's the theory of mind level of artificial intelligence. Self-aware is a super smart thing. It has a subconscious sentiments. It can read emotions. It is expected to be smarter than humans, but an ASI, which is a super intelligent AI that has not been designed yet. Okay, nothing today. There are laboratories which are working on this. Companies like Tesla are trying to build something. NASA is trying to build something, but nothing has come down very productive. So that's the basic type of AI. Now, when somebody says artificial intelligence is only like Anita is intelligent. Okay, but how does she become intelligent? How does a person become intelligent? What makes them intelligent? In the full screen mode, I'll do that. Okay. What makes a person intelligent? Okay, artificial intelligence is intelligence. When somebody says some person is intelligent, what makes them intelligent? Give me a minute, okay? I'm going to. Okay, Mustafa sir says that it is by learning, some person becomes intelligent. Yes, by learning. Okay, and what do we use to learn? Like what in a human allows them to learn? By perception. Yeah, okay, Mallishwar Rao sir. Navida ma'am says training. By training, we learn. Yes, we do. Okay. That is all. Are we busy doing the Kartika Deepam at home and not responding? Okay, there are only very few answers, but let's see. Okay, when we say some person is intelligent, okay, obviously it means their brain is functioning excellently well. That's what it means. Their brain is the key functioning part that allows them to be very intelligent, and the modules or the techniques that makes them intelligent is learning, training, doing a practice by using perceptual views. So all of those answers in there, that are the techniques that will enable the brain to become intelligent. Okay, so similarly, when we say machine learning, right, when we say machine is trying to learn something, we all know this is, see, I don't want to take through this entire presentation. Let me put it on because some people are not able to view. Okay, I'm not taking through this entire presentation. We have another presentation for our session, so this is only a preview. So artificial intelligence, it has so many different categories. As you see, it has machine learning, deep learning, expert system, NLPs, which is natural language processing, which includes text questioning, context classification, machine. speech, speech to text, text to speech, which you will see in customer services, vision, meshing, image recognition, robotics, and planning. So all of these are falling under the category of artificial intelligence. However, we are only focusing in this session about machine learning. What machine learning means is, I'm not again going to read all of this, but I'm going to tell you that it is a way, or it is a methodology in which we are trying to teach a machine, like a bot, like a robot. Somebody is teaching, but there has to be some level of methodology. Like perception is a methodology. Like ma'am said, perception is a methodology. They are using images. They're using data. This is exactly, say now you will develop correlation. Just don't look machine learning for cybersecurity as a case study and things like that. But let's look at, we learned about big data analytics for cyber analysis, right? So now you will bring that correlation while we learn the machine learning. The data that we were talking about the other day, the day before yesterday, on the day 3, that's exactly the data that is going to come, that is going to come in, that is going to be pulled inside and be taught to the machines, okay, in a specific way using specific algorithms. Okay, we'll talk about the algorithms in the next slide, but there is going to be specific methodology. For example, like the other day, right, I got some interesting answers. When you go to the class, how do you improvise the learning? Somebody said, I'll give revision. Somebody said, I will only cover important topics. Somebody said, I'll do ask them to encourage them to ask more questions. I will do motivational stuff so that they will learn for that particular topic well. So all those answers were a algorithm, right? Because that's the teacher's algorithm to train the students. Similar way, machine learning has algorithms that is written to train the machines. Okay, while we go further, we look at how well the machines could learn and what types it will use to learn the data that we are teaching them. Okay, let's okay, now I'm not sure if this is completely streaming. I also want, before we get into a real topic, I want to brush up on this topic. Okay, there are so many different types of machine learning. Okay, one is supervised learning, unsupervised, semi-supervised, and reinforced learning. Okay, when somebody says it is a supervised learning, okay, supervision in a class to that of a supervision on a data model. Okay, it is all exactly the same, or we can correlate to that of what we do in the classroom to that of what the machine is learning. When we say supervised learning, there is going to be labeled data sets. What is this word labeled data set? Why do we have to call it like that? Here are two different pictures, right? What is this picture? Classification and regression and stuffs like that, right? Why do I have these pictures? Is that when somebody says a machine is using a supervised learning model, then we are going to use a data and label it, in the sense you might have seen YouTube videos or you would have seen in the books. Okay, when there is take a picture of say a football and say that is a football. Okay, which means we are labeling an object with a name. Take an object like this. Okay, so that, and then name that as pen. Okay, so that is label. Take an object, put a label to it. Take my face, label it as Anita. So which means it is a labeled data set. Okay, when it says it is classifications in the sense, what we are trying to say is that whenever you see something like a face just like my face, okay, I will say this face is Indian. Okay, take another face of, say, an American's face, a person who has a better tone, a different blonde hair. Take that specifications, label them as, say, European or Australian, depending on the eye color. So that is a group of classifications. Okay. So there is a classification that is happening depending upon certain parameters. That is how we will label that particular entity and call as labeling that particular data set. And that is a classified methodology of supervised learning. Now I'll go back and tell you what spam is a classified way, because we are picking and choosing a lot of words, put them together. Okay, and we will teach the machine. We'll tell them, if you see Iranius, if you see data, if you see $55, if you see you won this thing, if you see say any harassment kind of words, then in the label of harassment we will teach harassment words. Okay, in the label of threat we will teach words of threat. Okay, in the words of phishing we will teach words that is relevant to phishing to the machine learning. Okay, so that is a classified model. When we say regressed model, it is only one set of data. For example, gold price. Okay, gold price, we will use the uh, numbers. We'll use the numbers. We will use the prices. We will use the cost. So a regressing model is that we will input the data to the machine every day, depending on the numbers we get on that particular day, or from a market or from a live feed, and tell them, hey, you know what? If you see this amount, which means it's a price rise. If you see that the money is going down on the gold market, then you will show that the trend is going down. Okay, so for finding a house or a stock which is better, or a gold price, something like that, is a regression model. Now, in both of these models, if you see, there is only a linear connection, 1:1. This is a pen, that is it, labeled as 1. The price of gold today is, say, 5,255 rupees, only 1. Okay, Anita's weight is, say, 95 kgs, and she is what? Her height is 6.5 or 6.3. Say her height to the weight BMI is only one value, which will be, say, 75 or 80 kgs. That will be an ideal BMI. So all of these will most probably be in a linear fashion. So that is what is a simplified model, supervised model. Like I said, this is a very, very direct model. For today, predictions, rainfall, stock, pricing, anything that you're seeing as such in a very general usage. Okay, a lot of stuff that we are seeing as a machine learning practical uses, right? Because recommendation on Facebook, while you watch a YouTube video as a recommendation, that is all from supervised learning. Okay, if you keep watching your astrology, you get the astrology inputs. If you keep watching something about cooking, you keep getting cooking. That's all from supervised learning, because the machine is supervising your activity, right? That's supervised. Let's look at the unsupervised. I have to stress on this machine learning types, because that's the basis of how the case studies are built and how machine learning comes into a practical usage. When we say unsupervised learning, the data sets that we are talking about, it doesn't have any labels. Okay, now the machine has to use some level of intelligence. So let's take this as an intelligent student. Okay, so in the class, there'll be some intelligent students, there'll be also average students, there'll be students who will learn only during the class and then they forget everything. So that's the supervised part. But now it's an unsupervised part. This part is going to try and make connections between what was taught to the machine in the earlier to that of what is going to be taught in the future, the inputs that it gets in the future. Let's look at the clustering model. Okay, finds hidden patterns in the data based on their similarities or differences. These patterns can relate to shape, size, or color, or use a group data of items, or create clusters. Okay, so now where do I use this? Why will I even use an unsupervised learning? Okay, because I want to teach the machine, and the machine has to do only with in terms of what is being taught. Okay, now we are not teaching this machine, but it is trying to cluster something. So when it comes to customer satisfaction, customer grouping, okay. Now I said supervised learning is going to give you recommendations based on what you're watching. But unsupervised learning is going to be even more advanced. It will group us together. Hey, Anita and a bunch of people, they're all very interested in, say, learning machine learning. So they are the focus group of people for pushing data that is, or videos that is relevant to machine learning. Okay, so this clustering model, what it tries to do is it tries to learn from the inputs that were labeled, and it will also use its intelligence to cluster and find associations. Okay, for example, find the relationship of one data to another data item. These techniques are often utilized in customer behavior analysis in e-commerce websites and OTT platforms. Okay, because this is for a larger group. See, you have to, you might have a question. Supervised learning is also pushing me recommendations. Unsupervised learning is also pushing me details, which is customer behavior analysis. So it is also giving me the recommendations. Both of them will give recommendations. What happens is that the supervised learning is only for one entity at a time, but unsupervised is doing associations. Okay, somebody from United States is watching uh, uh, white collar commercial show. Okay, somebody from India is watching white collar commercial show. Okay, somebody from Europe is also watching. So a bunch of people are focused on white collar show. A bunch of people from various countries and various server lines are watching, say, Korean series or movies. Okay, that kind of clustering and association is done by unsupervised learning. Okay, that's the thing. Semi-supervised learning. What this will do is it will use both the labeled and unlabeled data. So there is another picture. See, look at the top of my screen. You will see input data. I am teaching this machine with input data, which is an elephant, a snake, and a puppy or a dog. Say a dog. Okay, so I'm trying to use all of this input data. I'm giving only partial labels. I'm giving elephant and a snake. Okay, now I'll allow the machine to think an unlabeled data, which is dog. Even though I've given 3 inputs, I've taught the machine only 2 things. Okay, so but with using these 2 things, okay, it will try to predict other animal names. Okay, there will be, how does it do this? Okay, how does it do this? This is, now we'll have this question definitely. How is it even doing when the machine it is a machine, it is not being taught, it is only taught 2 labels. How will this do this? Then there is going to be algorithms which will tell them, okay, if you see 2 eyes, like 4 legs, okay, and if it has like ears which are big, but it doesn't have a trunk, in the if else statement, it is going to be an algorithm which it might be a dog, it might be a cat. Okay, so there will be algorithms which will be written in a different format, but that will not say any labels. Okay, it is about the machine to use the algorithm and guess, okay, probably this is what the picture is trying to show. Okay, so that level of learning will be unsupervised. Look at this. Label data is mainly information that has semantic tags so that the algorithm can interpret it. But unlabeled data does not have the information. Machine learning systems can learn to categorize unlabeled data using this combination. It will only categorize. But obviously, the machine will not know the name that it has to be dog. That will come from the database. It will have a humongous data. From the database, it will try to connect with the algorithm and see, okay, probably with all the inputs they've given and the picture, looking at the picture, I think I'll predict this as a dog, right? Okay, so that's about semi-supervised learning. Reinforced learning. This is inspired by how humans learn from the trial and error. So this is going to be, this is the kind of Indian style of parenting and learning, okay, because we do this reinforced learning with the kids at home. Okay, if you see, what we will tell them is, okay, if you finish the homework, I'm going to buy you a chocolate. If you finish the homework, I'm going to allow you, give you a 15 minutes window to watch like your favorite show. Okay, or if you do not finish this, you're going to repeat this, write this for 5 times, repeat this for 10 times. You're not attending my class tomorrow, you have to go to the library and find some article, or things like that is reinforced, because we want them to understand what they are learning and also understand the impact of not understanding the learning process. Exactly, this is what is happening in the reinforced learning. Here, an agent interacts with the environment and learns to make optimal decisions to maximize cumulative rewards. Okay, the agent receives feedback through rewards and penalties based on its action. Forget about, do not even read this, okay, because this is going to be way too much technical. Okay, so let's not go into this. The agent, the word agent, you know, it's a bot. Okay, so it's a bot. Here, look at this picture. Okay, this bot is being taught. Here is a machine learning algorithm which says, okay, you have to go to the environment, pick the device, okay, and place it into a different e-commerce place, okay, into a different shelf. So what happens is that if the agent understands the algorithm that is being taught to it, all the details that is given to it, and places it in the right shelf, it's fine. Otherwise, what happens is that the algorithm person or the person who has to tune the agent, they'll go back and fix the algorithm in such a way, okay, and say if you move all of these three, okay, then that is the end of the work for today. It will mark the end of task. Okay, so this kind of feedbacks and rewards will be given in the reinforced kind of learning. It is commonly used in robotics, game playing, and autonomous systems. Okay, so that is about the various types of ML. Okay, now what I will do is I will pause here for a minute because I don't want to go into deep learning or anything like that, because this is not even relevant to our session right now. I am not even watching the screen, so let's go back. All right. So what do we have questions about this? Because this is paramount importance to grasp and understand that this machine learning types, because we are going to learn about machine learning in cybersecurity for some certain case studies, right? So we have to understand what is supervised. What is that, Goshu sir? Okay. Do we have a question on supervised, unsupervised, semi-supervised? And what do we have? What else do we have? Reinforced. Do we have questions? You can put your questions on the chat if you have any questions. Are you with me? Are you all with me, or is there a problem in understanding? Am I very fast, or is it not interesting? Okay, Usha, thank you. Usha ma'am, thank you for responding. Yes. Okay. Okay, all right, all right, all right. If you can just, I want to ensure that you're able to grasp, because I don't want to be going. You can go ahead, ma'am. All right, John, sir. Wonderful. Okay. Wonderful. Okay. So this is nice. Now we want to go back and look at unsupervised model clustering method. Image-based data set, can we train them? Yes, we can train, Lokesh sir. Yes, obviously. Like I said, that it's one of the key ways, audios, videos, when we use large language models. Okay, there is image-based data set which we can train. Definitely, it can be done both in supervised, unsupervised, or in semi-supervised models. We can use image-based models for training, and also voice-based models, because that's how our customer bots are talking to us, right? When you log into, say, some customer website, Philips or Amazon, hey, I'm available here. My name is whatever, Stella. Can I help you? Okay, so that's the thing. Cybersecurity data set, can we train them? Exactly. Yes, sir. We can train them. Malishwara, sir, we can train them. So that is what exactly the question I was going to ask. Now, give me some inputs of, say, from the big data and big data analytics for cybersecurity, right? We were talking about multiple things. What all data can arrest the cyber threat? Okay. What data did we learn on the other day that can arrest the cyber threat, that can stop the cyber threat? What kind of data was analyzed during our big data analytics session? Do we have the notes or something? Because it is very relevant, it is very close, because big data analytics we learned certain things about cybersecurity. See, here is all the things that we can do to stop the cyber threat. What was that data? While you respond, I'm going to share my screen. Now you know how difficult it is for the students to take notes. Yeah? I'm going to share my screen again. All right. Okay, there's going to be a new screen which I'm sharing. Tell me if you can see my new screen with the content for today's presentation. Yes, okay, Pooja ma'am, thank you. All right, so here is my new screen. Even though I did not get any responses, that is fine. But I'm going to pull this into a. All right, so this is our day 6 program. Let's look at, like I said, machine learning. It is a subset of artificial intelligence. That was only a preview session. This is our real session. Okay, let's look at this. It's a subset of artificial intelligence that allows system to automatically identify features, information, patterns, data, determinators. So like I said, in our previous session, in the big data session, right, we will use historical information. We will use the history, we will use data of watching, we will use logs, login informations, network traffics. So what is relevant data for cybersecurity? This is all the relevant data for cybersecurity. Okay, so we will use this data to train our machine to find out a threat and make our cybersecurity strong. So that is historical data is transmitted to system that use algorithms to create machine learning models. So this is very general input you can find anywhere in Google. So the quality of a machine learning model depends on two key aspects. Okay, one is the quality of input data, because I cannot expect a threat to be stopped or an attack, cyber attack cannot stop if I don't have the right level of data. I have to find out, okay, what all botnets are possibly can impact me, what all ransom virus can impact me, what all worms can impact my system, what all network traffic, what kind of phishing can happen, how a third party can attack my system. So I have to have a quality input of data in terms of cybersecurity to avoid the threats, okay, or the attacks. The algorithm alignment with the use case, okay, because not every algorithm can be used everywhere. In today's session, we will not focus on every algorithm that is used, but I will definitely give you an overview of what all algorithms are there in machine learning and what they are specifically catering to be helpful for. All right. Why focus on AI/ML for cybersecurity? Okay. So according to a recent industry report, the global AI and cybersecurity market is projected to witness a substantial growth with a CAGR of over 20% during the forecast period. This growth trajectory underscores the increasing reliance on AI-driven solutions to combat evolving cyber threats. It's a global rating. It is given. It is an annual global rating. Okay, cyber annual global rating that is given. That is over 20% forecast is done. In terms, if we use AI-driven solutions, there is high chances that cyber threat can be stopped, is what they think. Okay, with this backdrop in mind, we shall delve into compelling case studies that highlight how AI is reshaping cybersecurity stats. That's just a word for you to learn, read later. It has nothing to relevant to the session. Okay, now let's look at the algorithms, because if cyber threat or the attack has to be stopped, like I said, it all starts with the data, and it also it depends on how well the machine can learn from the data. Even though the machine has to learn, I have to tell how you should learn. Like mathematics, how do you do algebra? How do we do mean and metrics? So things like that, there is a different way of teaching each possibility of math. Calculus is done differently, expressions are done differently, algebra is done differently, numericals are done differently. If it is a logical problem, it is done differently. So in a similar way, for learning every attack or every relevant data of cybersecurity, is a different algorithm. One is this is only a limited content, okay, but there are much more to this. Decision tree algorithm for detecting and classifying attacks. Okay, so that's for that. Dimensionality reduction algorithms for removing noise and irrelevant data, like say scam or spam. K means clustering for detecting malware. K nearest neighbor classification for facial recognition used for authentication. So that's like your phone even uses KNNs, okay, these days. So linear regression for predicting network security outcomes, logistic regression for fraud detection, naive-Bayes algorithm, that's for intrusion detection, random forest algorithm for classifying phishing attacks. Okay, support vector machine, that's very popular one because it does classification, detecting, predicting, blacklisting IPs, addresses, and ports. This is, I have seen many places in IT where SVM is very popular. The others are definitely used because KNN is also popular. That's something that you will also know because facial recognition on your phones, you use an Android or an iOS, doesn't matter, but you will still see that there is a facial recognition that's used depending on the phone model that we use, right? The other algorithms are sitting over there, okay? Since our focus today is for the case study, I will still have to give you all the background before we look into the real case study. So that's the algorithm part. And then why I wanted to give you the preview of the models, right? The reason I wanted to give preview, excuse me. The reason I wanted to give the preview of the models is because we want to understand the model first and then look into what it can do and how it can do. Okay. So what the model does is, the model is in cybersecurity, if it is a supervised model, obviously, like I said, it is going to use the label the data set to train the algorithms. Okay. So now let's look at what all it could do. Number one, identify unique labels of network risk, such as scanning, spoofing, and things like that. And then there is predicting or classifying a target variable for a specific security threat, distributed denial of services attack. So what is this distributed denial of services attack? Okay, let me give an example. Let's take the railway reservation system. Okay, so that is a particular system that everybody, I mean, throughout India, everyone would be interested to use when they want to make reservations, especially when the Tatkal opens. Let's take a scenario of Tatkal. So when the time is very peak and we want to do the Tatkal reservation, what happens is that there is a botnet, there is a bot. Okay, what that does is that one is starting to produce multiple user loads. Okay, because what is a user load here is, I'm a user, you're a user. Similar to us, there will be millions of users or say lakhs of users in India. When the load on the system is high, what happens is what happens to the system is that it will not be able to respond to any of us. So which means there is a denial. So you'll not be able to access denied, you're not able to talk. So what happens is this bot will try to attack a specific system by forcing load on it. It will simulate the load. In the sense, instead of the real 100,000 users, this will simulate, the bot will start to send the threat as a simulation. And what happens is, fake or unreal 100,000 users will log into the application and it will destroy and it will bring down the application totally down. The services will be down. Sometimes we have these attacks in banking applications, railway applications, anywhere the public interference is more. Okay, so DDoS, if you learn it, some of the key American institutes, they have this DDoS attack often happening. Okay, so that is one thing that is happening that can be learned by supervised model. Training models on banning and malicious samples to help them predict whether new samples are malicious. Okay, so in addition to machine learning in cybersecurity, supervised learning can be used for binary classification. So it can classify, like I said, this is all about labeling and classifying. So it can classify data into two categories. This is why I showed you the other slide where it was having categories, right? We saw for the first one was categorization, the other one was regression. So multi-class classification, choose between more than two types of answers. Regressing model, So that model uses predicted continuous values. Like I said, it is predicting the continuous values. Depending on 5 days, there is rain, 25 degrees, rain, 22 degrees, rain. It will predict the future, say, okay, probably there is going to be rain for another few days. So that is the regression model, right? TensorFlow learning, combining the predictions of multiple machine learning model to produce a accurate prediction, right? So that is about supervised learning model and what all it could do, what kind of technique it uses. It still has to use algorithm. So linear, logistic, naive, neural, random forest, support vector machine. These are all, not all, few of the techniques which I have seen can be used when we are trying to protect or make a machine learning algorithm to learn in a supervised way. Like I said, if you look at all of these examples, right, scanning or spoofing or a security threat using the samples, this is all relevant to only when there is predicted outcome, only when there is data that is already classified, categorized, and given to the application. So now you can correlate between what we learned about supervised machine learning to that of what it is happening in cybersecurity, right? How the machine is learning. And then we will look at the reinforced model of learning. In every model, probably we will see it is learning the similar thing, but it in a different format. Okay, reinforced machine learning trains the algorithm by trial and error. Like I already said, it will only give rewards or it will give learnings. Positive or negative cues are given registered along the way with the algorithm programmed to seek affirmations or avoid penalties. Okay, so here adversarial simulation to train ML models to identify and respond to attacks in real time. So what happens is that in real time the data will be monitored in the sense. I'm not sure how much of us can relate to this, but how many of us can relate to this. But if we have an IT organization, like I said, if we have the college organization, okay, and there is real-time monitoring happening for your cloud system. So if there is a real-time monitoring happening, in the sense it will be watching, okay, how many users are logging into the cloud application, how many of them are hitting my applications, how many of them are trying to attack, okay, because it will also be watching the attacks that is happening or the threats that is coming in. But if it sees an adversarial simulation, for example, there is probably certain spam emails which is already populating, or certain attackers which are attacking the system on a real time, which is being eliminated by the system. But if it is anonymously from, say, from Europe, somebody is attacking the computer applications or the cloud of private cloud of college, say Wales College. What happens is that it is very adversarial simulation, but it is mandatory in the reinforced machine learning methodology that the machine is able to identify the threat. Okay, that is because it is not using a linear model. Let's look at the technique, because we understand deep deterministic, deep Q networking, policy grading. These are not linear methodologies, because see, look at these methods. These are all very plain vanilla methods: linear, logistic, naive, or neural. See, when you go back from the session, right, when you have time, probably take a look at this. You might have seen, most of the teachers might know, but if you haven't, then take a look at this in neural networks or linear, logistics. All of these are one of these. If we look at this, this is all direct models, but this isn't a direct model. It has to have a deep networking, so it will learn from pattern to pattern, label to label, using label data, using unlabeled data. So autonomous intrusion detection. So it has to be intrusive. Okay, maybe the attack can happen tomorrow, maybe because of the sequences that happened previous year during the same time. For example, a retail shop is getting attacked during the Christmas season in the United States, which means it is an intrusion. That kind of learning the machine does is reinforced. Cyber physical systems, some physical systems can also impact. Distributed denial defenses. So this is not identifying the attack, it has to defense when it comes to reinforced. Okay, a model of environment is known as, but an analytical solution is unavailable. Okay, so what happens is that they know that the threat is happening, but there is no solution, which means they will alert the application. Only a simulation model of the environment is given. Okay, but they do not know what threat is happening. The only way to collect environmental interaction is to interact with it. Okay, for example, a bot or a device is trying to attack. They know that there is a ransomware or there is a botnet that is trying to attack the network, but they do not know how to find out. Then they will use a different algorithm. They will try to interact. They will the network side, IT side will also try to create a botnet, and then they will try to interact with the new environment that is coming in connection and try to learn. The machine will try to learn. So these are some reinforced learning methodologies and the techniques that will be used. And unsupervised machine learning, like I said, to analyze and cluster unlabeled data, example, photos, images, videos, recordings, articles, social media posts. It will take everything and then the data will be given to the machine. Okay, so this is also doing similar thing, but in a different, detecting unusual behavior, new attack patterns, zero-day attacks, anomaly detection. See, this is all mitigating, okay, mitigating zero-day attacks, anomaly detection, association mining, clustering, dimensionality reduction. If you look at all of these words, these all will sum into the same category. Only the technical word is different. Okay? But what it happens is, if each one of this pattern is trying to stop an attack, okay, whether it is a zero-day attack before even the launch is happening or an unusual behavior, but the technique that it is using, when the complexity, the technique that is used is very, very different. What Tesla will use, probably Amazon will not use, because Amazon likes what recommendations. It wants to do the recommendations only for users. When that is a good example. Okay, Amazon. Okay, Amazon, when it does recommendations, it will probably use supervised machine learning, use linear method. But when it wants to find out that it does not want to have a DDoS defense, right? It does not. When millions of users across the world are trying to use Amazon shopping services, it does not want a bot to create another 200 million people to come and attack. Okay, then it will use the reinforced model with DDQ systems or DQN algorithms. But when it comes to, see, they're trying to implement a new functionality, and before even they go live, if there is a zero-day attack happening, obviously they will teach all the zero-day attacks that have happened in the future in the unsupervised learning, and also some of them it will predict. Okay, then K-means clustering, neural networks, principal compound analysis will be used. So basically it is all to stop the threat at various levels using various techniques. Okay, so that's about unsupervised learning. And semi-supervised. Okay, this semi-supervised learning, if you look at this, right, this is slightly different. This is why this is slightly different is machine learning in cybersecurity blends supervised and unsupervised machine learning. Most of the semi-supervised learning, they are only focusing on the malware, ransomware, malicious, adversarial, fraud detection, labeling data, machine translation. So this is mostly focusing on the viruses or the worms that is getting attacked in the semi-supervised model. Okay, and they are using label propagation, pseudo labeling, self-training, consistent regularization techniques to enable the machine to learn to find out what kind of viruses or fraud can happen. Okay, so in summary, from all of these methodologies, or we did not learn many, but 4 methods, 4 types of machine learning. What in a summary or in a wholesome or in a bigger picture, what this is doing is it is trying to stop a virus or an attack or a fraudulent detection or say a malicious entity that is entering in there, or a network trafficking. Okay, so this is what every model or every machine learning type is trying to address using a different technique. Okay, but we also have to look at the case study, which is very focused for our session today. Okay, this is the benefits of using ML, because all of that, the summary that I was talking about, what is the benefits when somebody is using BYOD, CYOD, if you are bringing your own device or choose your own device. Okay, this might not be a very common scenario in the college. Okay, but this is very common scenario in IT. When they say BYOD, I have to bring my own device to the company. I can bring any virus, I can bring any worm, I can bring anything in there. Okay, what happens is that as soon as I connect to the network, I can even be a very much of a threat. I can send viruses from my applications. I can activate my own botnet and spoil that entire network. But what happens is that when they have a cybersecurity enabled using ML, when I use my device, first it will scan my device for all the erroneous data, for all the viruses it has. It will first ask me to delete everything even before it logs me back into the network. Okay, so that is what it is. Automates cybersecurity process, detect threats. Like I said, that's a benefit. Adaptable and proactive defense. So not just detecting, sometimes it does a defensive mechanism. It cannot be like it will do prevention. Expedites threat detection, identifies hard to find network vulnerabilities, internalizes learning from previous attacks, previous future attacks based on similar profiles, makes it easier for security analysts to quickly identify. That's another thing. Powers sophisticated authentication mechanisms such as facial, finger, motion tracking, retinal scanners, voice recognition. Helps prevent security threat against endpoints. Provides in basically, I do not want to read. I wanted only to tell you that this is all about preventing the threat, identifying the threat in various formats in terms of, like I said, phishing, or in terms of proactive defenses, network authentication, malwares, recognizing your history, browser details, and all of these things. Okay, so that is the kind of data that it will use, and it will stop the cyber threat that will happen using a machine learning. So that is all the benefits. Okay, so here are some use cases. So that is different from the case study, right? Because case study is different from the use cases, where all it can be used, where all it has been used. I am not going to read this at all because I will not be able to focus on the case study if this is going to be read. Okay, but we will look at this at a very quick shot. Let's give a quick shot. Detecting and preventing DDoS attacks and botnets. Like I said, models can be trained to analyze a large volume of traffic between different endpoints to proactively identify the predict DDoS attack, application, protocol level, volumetric attacks, and botnets. So at every level, application level, database level, at every level, they will set up DDoS algorithms to make sure or to ensure that the bots are not attacking the application. Okay, and detecting web shells, that is another methodology, because from unknown pages or unknown websites, if there is an attack that is happening, then that will be detected. Threat detection and classification, that's another. Fighting malvirus, obviously. Models can be trained to help antivirus solutions fight all types of malvirus, adware, backdoors, ransomware, spyware, trojans. It can fight anything. Network risk scoring. Okay, if there is, we learned this in our data analytics class, right? Because they will do risk assessment. That was one of the techniques that big data will use of what is the risk scoring for a particular event. So that is also one of the use case of machine learning. So the machine will try to do the risk scoring and prioritize which risk has to be prevented first if they have multiple risks or multiple attacks, right? So the thing is, we each one of us have to correlate between our previous session to that of this, which will make it meaningful. And then protecting against application attacks. It cannot attack it to detect HTTPS anomaly or SQL excesses. Securing mobile endpoints. Okay. Again, what happens is that voice-based training will be given to the mobiles. Okay, what to identify a bot or to differentiate the owner's voice and the hacker's voice. So those kind of security endpoints will be enabled. Security operations SOCs. That is kind of very high level security threat which will be done in IT organizations for monitoring and detecting security attacks. Phishing, we all know, because we will get get real time in real time. Each one of us would be getting emails stating that, hey, you got a lottery, you got this, you got that. Here is click on this link and it will, you will find out you have a money in your bank account. Fill all these details, then I'll give you 20% discount on whatever. So this kind of phishing emails can come to anyone. Okay, so that is malicious and phishing types it can prevent. Task automation. If there is a, this is another thing I want to read. Machine learning excels at automating time-consuming, repetitive, and error-prone security tasks, such as network log analysis, threat analysis, triaging intelligence, vulnerability assessment. In addition to providing automation, machine learning can identify threats and anomalies at the rate that is faster and far more effective. What this is trying to say is, when these tasks are automated, okay, what kind of task? Network log analysis. Nobody has to sit and do the analysis, right? So that is a use case. That is where ML is coming into picture. So it does network analysis, threat analysis, triaging. What is triaging? It will look at the past history, current history, and also predict the future. It will triage between what has happened, what is the root cause for a certain attack. All that things will be done. That is again a use case. Email monitoring, natural language processing. NLP is a type where it will be using certain level of ML logics, sorry, AI logics, apply a certain level of malware and viruses without even opening the message that can spread across into our system. So this use case of using ML will also prevent us and monitor us from emails being hacked. Okay, so that is another usage. Those two slides are not relevant to our case. Okay, so I want to pause just for a minute. Okay, before we look into the case study. Are we able to correlate between unstructured data? Okay. I think I've been talking for such a long time. Okay. I know this is quite exhaustive. Okay, so what I want to ask is this providing an insight of how we can correlate big data to that of using of artificial intelligence, to that of training the machine language, and how and what can be stopped. For example, tomorrow, if I have a case in the let's say I'll give an example now. Let's ask some questions. Okay, if in the college, okay, it is expected that one of our professors who has attended this are asked a question. Hey, same as Sangeeta, what happens is that there is a threat we are foreseeing in the cloud space or in the entire network of our IT systems. Okay, what will you say? What will you say? How will you attack the case? What all things that you will think about? We can use this preventive technique. We can design a machine learning algorithm like this, a machine learning model like this. What will be your suggestions? Okay, because that is what we have learned so far. So we have to apply it somewhere, right? So if our case, what is a case study? A case study is something that we have to use somewhere. I'll tell you one story, okay, while you're thinking about it. I was talking to my mom a few days back about this machine learning session. I was asking her, hey, machine learning is that I'm trying to teach the professors, research people. I'll tell you what machine learning is. I was teaching her. I was telling her that, see, machine learning is that I'll try to teach a machine with certain inputs, certain data, certain videos, audios, messages, space, and all that. And then I was asking her, okay, I'll tell you what, if I have to build a machine for you or teach a bot about certain thing, okay, I was asking her, what do you want to automate? What do you want to do for yourself? What kind of bot do you want? It is very funny. Okay, immediately she responded to me, ஒரு hair color போடுற ஒரு bot எனக்கு கண்டுபிடிச்சு கொடு. She was really telling me this. She was saying that, okay, give me a bot that can do hair color for me, because she needs it. Definitely she has to do color. She's coloring her hair every week, and she thinks that I want to teach the machine. She was also telling me, tell the machine that it has to put a cotton beside my ears. It has to not put out anything on my face. It has only to do the roots. It shouldn't do my hair. And she was giving me all of those specifications. I was asking her because I wanted her to she was asking me questions on and on under machine learning. She was asking. So I was saying her that this is what it is happening. You tell me what you want. She said she want a hair coloring bot. Okay. And I was amazed. Okay. She knows specifications. She knows what kind of bot she wants. And if I have to do anything like that, I thought I will do a supervised model, because it obviously has to learn everything. It cannot be intuitive. It is not going to get any erroneous virus or anything. It is not going to get cyber threat or attack. All it has to know is that it has to recognize my mother's face. It has to understand the data between the root and the full length. It has to understand the color that it has to apply, and it has to use its hands to do the coloring. So it has to be pretty much supervised learning model. I can use linear or neural just to build that bot. Okay, something like that. Now, I'll give the assessment link. I'll definitely, okay, that's the assessment link. All right. And you tell me what is the case if in the college a cloud is getting attacked, okay, and your principal or your correspondents are asking one of the professors or a group of professors to come and tell, hey, tell me what kind of machine learning mechanism that we can establish. What kind of algorithms do you think can be applied from this learning, right? What do you think can be done? Which one is optimal? Which machine learning type is optimal to prevent cloud attack in a college environment? And why? Are you not listening? Okay, John sir, you say it is a support vector machine. Okay, and Usha ma'am says I can use a reinforced model. Okay, so reinforcement model. Okay, of course SVM. Yes, Usha ma'am. So that will be the model. That will be the technique, right? And which one will we do supervised, unsupervised, or will yeah, Usha ma'am thinks she will choose a reinforcement model. Anybody else choose a different one, like say a semi-supervised is my better choice? That do anybody? Okay, supervised is another model. Okay, yes ma'am. Linear regression, that is the methodology. Okay. Okay. We will use deep learning methods. All right. Okay, got it. CNN, Ganesh Saris. Okay, we will use one of those techniques. I would predominantly think, if I was asked that question, I will predominantly think that I want to use a unsupervised model, because it can use labeled and unlabeled data sets. It will try to find the malware viruses, but I will use a combination of algorithms, because I might not recommend to use just one algorithm. I will use a combination of algorithms to prevent cyber threat. Is there a question? Sorry. Yes, it depends on the type of attack. Okay, so I'll quickly wrap this call. Is it okay to extend it, ma'am, to another 5 minutes? Ma'am, can we extend the call for another 5 minutes?
Now they have the test session.
Oh, they have the test session. Okay, they can't extend it. We can't extend it to another 5 minutes.
You have to give. I'll give 5 minutes. You conclude. Okay.
Yeah. Okay. I'll just finish this up. Okay, because they have to look at the case study. Okay. Here is the case studies. Okay, because that is the key part that we wanted to cover. Right. That's the key. But that is nothing new. IBM is using AI for cybersecurity. The background is IBM is a global leader, technology and consultants has been in the forefront. What they are trying, they faced a challenge of detecting and mitigating increased cyber threat. IBM turned into security operations. So they are using Watson for cyber security. They're using machine language, natural language processing to identify, okay, how they are using the data, unstructured data, blogs, research papers, that's all used for threat. And what they have found is improved threat detection, enhanced accuracy and scalability. So that's the kind of data they are using the Watson model for cybersecurity. IBM has faced a lot of threats. So that's exactly why this one of the case studies that IBM has published. Okay. So what they think is they have 60% reduction of time for investigating the security incidents, which is a great improvement. And there is reduction the number of false positives by 30%. So this is all happening because of the ML algorithms and logic that they have implemented. See, I do not want to focus on the case study in the beginning because only if we understand the logics, then we understand why they have used and what they have achieved. Okay, so that's about the IBM. Microsoft is also using. What happens is that they are facing millions of cyber threats daily. Its extensive product and service ecosystem to enhance its cyber defense. Microsoft has leveraged AI to protect its cloud infrastructure and customer data. Okay, so they're trying to protect this. So what they have used is Microsoft Intelligent Security Graph, okay, which processes over 6.5 trillion signals daily from its products and services. Okay, so that's how they have implemented Microsoft integrated AI and machine learning, which is using a Microsoft Intelligent Security Graph. So they are looking at the anomalies, threats, and actionable items. What happens is threat detection response time has reduced, threat detection rate has improved, phishing attacks has reduced by 40%. It is giving a proactive defense mechanism. See, this is all that we have already learned, but this is a case study that shows how it is implemented. I'm not going to read this. I'll leave it for reading at the end because I just got 5 minutes. So broadest use of AI for fraud detection. So like I said, right from the beginning of the session, it is all about stopping the attacks, malviruses, and preventing the cloud or the environment or the networks. So how it is done, each company is doing it in a different way. See here, it is Dark Traces self-learning AI. That's what it is being used in the Prodier's use of AI for fraud detection, right? This is kind of a bank application. So that is about the end of the case study for machine learning. Okay. Thank you very much for that extended time, ma'am. And I'm extremely sorry for joining late. We would have done it a little bit.
No issue. No issue. I told that raining in that area. Much
It is also raining here. It is heavily raining. It's still raining.
Heavily rained. Okay. So that
Yes.
I told the participants to wait up to that 5:10.
Yeah, sure.
And then we gave break for them also.
Sure.
The sessions are continuously running from 2 o'clock onwards. So they take up to 15 minutes.
Okay. Mustafa sir, thank you so much.
You check your chat box, Anita. You have appreciations from the participants.
Yes, I am. I am watching the chat box. Thank you so much. Any deep learning algorithms for cybersecurity, sir? Everything that I mentioned, like linear, CPQ, CDQs, everything are for
previous one. I am always appreciate your presentation, ma'am.
What is yeah, Mustafa sir has given a good feedback. They are simple, easy to understand, and straight to the point, quickly, effectively. We sincerely thank you for sharing your valuable knowledge. This is thank you, sir. Thank you, Mustafa sir, for the appreciation. I love that.
Okay.
Okay. This is wonderful. I am Ramatilgam ma'am. Very informative session. Thank you. Deeply honored because this is a very good session.
We will take the photo session.
Thank you.
I ask everyone to switch on your camera to take the photo. Participants, please switch on your camera.
அமைதியா இருக்கு கொஞ்ச நேரம் சரியா
Huh? I ask the participants to switch on your camera. Please come for photo session. This is the final session of FDP.
Camera is disabled, ma'am.
Please
Ma'am, now enabled.
Okay. Okay, thank you.
Thank you.
Thank you, Anita.
Thanks, ma'am. Thanks for the opportunity, and thank you everyone for participating and being very interactive. Ma'am, will these presentations be shared with the team? Like,
Yeah, I shared the link to the team. Shared.
I'll
Okay,
share
you
the other two presentations as well. The other one, the AIML presentation, that is my own presentation.
Okay,
Yeah.
you send to me.
Yes, ma'am. All right. Thank you very much. Okay. I'll maybe in the future I'll meet you all in a different session.
I am so happy to have you, Anita, because today is the end of the FDP. We have a nice presentation with use cases and everything, and clear explanation about all the AML with the cyber security, and fulfill of the FDP is completed. All the sessions are completed very nice. Oh, thank you very much, Anita.
Thank you all again. Bye-bye.
Bye. Participants, you are requested to take the test, and assessment link will be shared in the WhatsApp group also, and everyone should complete the test. Then you have to fill the feedback in your Atal portal also. Okay, in the portal you have to fill the feedback, and then you can download your certificate. It may take 1 or 2 days, or it may be 1 week, so you can get the certificate. Once you filled the feedback form in the Atal portal only, you can download your certificate. Okay, take the test and come and join again with the valedictory function. Okay, all are requested to join the valedictory function at 7:30 to 8, only half an hour. So join and grace the occasion. Thank you.